Hey everyone, welcome back to the channel. So first of all, two quick announcements before we get started. Firstly, this video is part of a course that I developed on Kotlin design patterns, where I cover a lot of the commonly used design patterns and some less commonly used ones. It's very useful for your Kotlin and Android development. I've spent more than a month building the course and over 10 years gathering the knowledge for it. It's getting some very positive reviews, so do check it out. Link with a discount in the description. Second, if you're not interested in the course but you still want to support my work, I have set up a Patreon account. If you like the free content I'm putting out, please consider supporting me there. All right, so that's all for the announcements. Now let's get on with the video. All right, so let's talk about the factory method. As the name suggests, factory refers to something that creates something else, some product, right? In our specific case for Kotlin development, here we use the factory method to provide some functionality or some instantiation for the calling elements. Okay, so let me just explain what that means. So first of all, let's assume we have a type of currency, right? This can be an interface or an abstract class. And here we have a few instantiations of that concept. Now, if we want to create a country that implements a specific currency, then that particular country needs to know what kind of currency it needs, right? So the object country, when it is created, needs to know how to create the object currency. Okay, so it needs to have all the details of the lower level implementation, right? Now, what we want to do is ideally we would like to abstract the implementation of currency from the country. They are two separate entities, and there's no reason for them to, for the country to know how to instantiate this lower level element, right? So that means we can create a currency factory. So the country can simply ask the currency factory to provide a specific currency based on some information that we provide, right? So here we would provide, let's say, the country type, okay? And then currency factory will provide the specific currency for that country that is required, right? So the functionality to implement currency is now in the factory, whereas the country is only concerned with the details of its own implementation. So basically, to sum up, factory method provides a way to access functionality without caring about implementation. So we introduce a level of separation there, which is always a good idea in software development because that separates functionality and provides a whole lot of advantages. So some of the advantages might be, like I mentioned, separation of concerns, might be testability, right? So it allows us to test elements in separate order. Now, of course, if we have separation of concerns, we also have less impact that some changes might have on other parts that are not intended. So reduction in bug introduction, right? So if you change one part of the code, that means another part of the code will not be affected necessarily, right? So it's always a good idea to separate things, and it allows us it allows testability as well. So let's try it out in our code. Let's implement a small structure here just to show you how you can go about implementing this yourself. So let's go ahead and create a new Kotlin file, and I'm going to call this factory method. Okay, we don't necessarily need a class here. So the first thing we need to do is we need to define the country, right? So I'm going to create a sealed class country. Okay, now there's a few different ways to create the subsequent objects, so the countries, right? So first of all, we could have an object of, let's call it Spain, which is going to be a country. Okay, so it inherits from country. We can also have a class, let's call this Greece, and this implements from country as well. And Greece can also have some information as well, so val some property. Okay, we need the type. Let's put a string here. And then we can also have a data class that doesn't really matter. Let's say USA, and here also inherits from country. This also requires a constructor, so let's add some property of type string. And we can also have an object inside the class country. Let's say object Canada is going to also inherit from country. All right, so all these objects will need instantiation of a currency. So let's define a class currency. And val currency code is going to be a string. So all these, oh, sorry, this needs to be the constructor here. Okay, so the class currency requires a code for that currency. So all these countries need to have a currency. Okay, we don't want the functionality to be provided for each and every one separately. Okay, we would like to have some method that provides us the functionality that we require, the instantiation of the currency. So here we can say object currency factory. Okay, and here is the method fun currency for country. And here we provide the country and we give the currency. Okay, and we will simply return. And here we can provide any functionality we want to decide which currency goes for which country. Okay, so for me, I'm going to say when country. Now so when the country is Greece, or let's start with Spain, because that's how we started with. So if it's Spain, then the currency provided is going to be currency of euro. If it's Greece, then the currency is also euro. Now, the cool thing about this is that when we use the when construct, here it must be exhaustive. So it also needs USA and Canada as well, right? So here I'm going to say is USA. Okay, currency for USA is United States dollar. And if it is Canada, okay, then currency is going to be Canadian dollar. So of course this is exhaustive. So if I want to add another country here, let's say class Poland, that extends country, then this when construct will require me to add Poland. So this will not even compile before we add the correct functionality here. So I'm going to comment that out. Okay, so this is the general structure, right? Let's add a test for us to run this code. And I'm going to say class factory method test at test fun. Let's call this currency test. All right, so let's say val Greek currency is going to be currency factory dot currency for country, and here we have to create a Greece object. Does Greece need anything else? Yes, some property. This doesn't really matter, and that's it. Dot code. Okay, so we are taking the code of the currency here. So Greek currency, and then I'm going to print line Greek currency dollar Greek currency. Okay, let's do another one. Val USA currency is going to be currency factory dot currency for country, and here I have USA, and I need some property here as well, dot code. Okay, and I'm going to print line that message as well. USA currency dollar USA currency. All right, so that is the output. Now let's create a few tests, assertions, and make sure you select the assert J ones. Dot assert that here we have Greek currency. I mistyped the Greek here and here. Okay, so Greek currency dot is equal to, and we're expecting the euro here, and I'm going to duplicate that, Command or Control D to duplicate, and USA currency is going to be United States dollar. Okay, so let's go ahead and run the code and see what the output is. All right, there we go. So the print line here is going to give us euros. The second print line is going to give us United States dollar. And of course, the tests will pass, right? We are getting euros and dollars. But the main idea is not the test. It's more the way we construct our factory method. So the factory method is going to know exactly what currency is needed for each particular country that we provide here, right? So that is the main structure of our factory method design pattern.